Welcome everybody. I'm Lucian and I'd like to welcome our speakers. Thank you our sponsor for supporting this event, Active Countermeasure Armis and Adolos. And with that, I'm going to turn it over to Dragos, who will moderate this exciting panel on the foundation of the connected industry, industrial cybersecurity. Dragos, the floor is yours.
Thanks, Lucian. Good morning to everyone, good afternoon or good evening from wherever you are watching us. As Lucian said, I will be the moderator for this track. There will be an exciting discussion about ICS security, about risks, strategy, and solutions in this new, let's say, emerging area. And together with me, I have some really cool gentlemen. I have Eric, I have Joe, Ulrich, Jack, and William, who are going to delight us with some spicy security stuff. So please feel free to pop up your questions, and I will kindly ask you to name the speaker to whom you are addressing the question, so that we know at the end of the panel to whom the question is addressed. So there will be around 1 hour and 40 minutes of interesting discussions, and after each panel, after each speaker, we will have a couple of minutes, 10 minutes of Q&A, where we are going to discuss about your questions. So I will start with Eric. Eric Byers will talk about ICS supply chain security, and I will present in a couple of words Eric. It's let's say an honor to present him. He is widely recognized as one of the world's leading experts in the field of industrial control systems and industrial IoT cybersecurity. He is also really nice thing. He's the inventor of Tofino security technology. Maybe you have heard about it. Is the most widely deployed ICS specific firewall in the world, which is licensed by industry giants like Honeywell, Schneider Electric, or Caterpillar. Eric is also known for his leadership in international standards and research for industrial communication. So please welcome Eric Byers. So Eric, the stage is yours.
Well, thank you very much. It's a real honor to be here. And today I want to talk about supply chain security for software used in industrial control systems. And what I've learned over that, I've been working on and concerned with supply chain security now since about 2014 for reasons I'll explain in a second. And as I've studied this, thanks to a very, very nice grant by the Department of Homeland Security for the last 4 years, I've learned that everyone has a different perspective. Everyone has a different idea of what supply chain security really is about. Let me give you a few examples. I'm going to start with what I thought it was when I started back in 2014. And that was the attackers modifying software and basically releasing counterfeit software. And the Dragonfly attacks are a great example. In this case, some cyber attackers, probably Eastern European driven, attacked the vendor websites for 3 ICS vendors and replaced the software that was there for their customers with new Trojanized versions that contained the malware called Havocs. Now, we've done a good job in the industrial world to teach our technicians to patch early and patch often. And sure enough, within days of that software being up there, there were hundreds of technicians downloading that software and installing it. In the one company that I did a deep analysis of, about 280 packages were downloaded in the 2 weeks that that software was up there. The technicians got it onto the plant floor no matter what, because they believed it was coming from a trusted vendor. And they would walk right past whitelisting, they'd walk it past the firewalls, they'd ignore alarms coming from antivirus. And of course, once it was installed, it would call back home to the attackers, and the attackers now had a control point deep inside the factory. So this exploiting the supplier and user trust was what I thought supply chain security was all about. Well, I quickly, immediately thought, well, code signing will fix this, but we learned with Stuxnet that code signing isn't the perfect solution. And subsequently, I've done a lot of research on code signing, and it is a useful tool, but it is no silver bullet. There's over 1 million pieces of malware out there code signed because it's actually a way to get your malware approved and running on a plant floor or anywhere else. So we have a problem with code signing. It's useful, but it's no silver bullet. I quickly learned also from many customers as I did my research that the bad guys are only part of the problem. Malware is only a little bit of the issue, because what was happening is vulnerabilities are being included or part of third-party products that get installed into plants that, and we don't even know. For example, Gemalto licensing tools. How many people out there think they're running Gemalto or know they're running Gemalto? Very few. But if you're an ABB customer or a GE customer or a Siemens customer, you're running Gemalto and you don't even know what vulnerabilities are included. So on one other one, and that really struck me, I was talking to, working with a number of large oil companies, and they pointed out that bad guys don't even need to get you to load malware. They can just trick your staff into loading old versions with vulnerabilities, and they have a door in. Now, we all know we're not supposed to be loading Windows XP, but who knows what version of a particular drive controller firmware package is the one with vulnerabilities. The reality is nobody really understands all the intricacies of version control on the plant floor when it comes to software, and what is vulnerable, what isn't. So at this point, I've got a little survey to try and find out what you guys think is important and what's. So Lucian, do you want to pop up that survey? Oh, maybe not. Hey, Lucian, lost you out there. All right. Okay. Well, I'm not sure if that survey's working. Ah, there it is. Okay. So, all right. Start selecting. What do you think is the most important security control you need to deal with when it comes to software? What's most important to you? So we'll hold this for a minute or two. Well, not a minute or two. We'll hold this for a minute, and then we'll see some results. Click away, everybody. All right. Well, what do you think? Shall we move on here?
And all right, here we go. We end and share results.
Okay, let's see some results. Okay. Well, it looks like just about half of you out there thinking tracking vulnerabilities in your subcomponents is what really winds you up. But validating the integrity of new software is also really important for at least a third of you. So that's basically what I was finding too as I go out and talk to people. Thank you very much, Lucian, for running that. Okay, so let's talk about some solutions. And here we go. No, you want to head to the next slide. Why is that not? There it is. Great. So one of the things I learned very quickly is, given enough time, I could figure out whether a package should or should not be loaded. But it was hard. It would take me a lot of time. And the poor technician out in the plant floor, he's dealing with thousands of devices. He's dealing with hundreds of vendors. He can use hundreds of different tools, some free, some crazily expensive. And he can look at hundreds of different databases. And the reality is there's so much information, nobody does any of this. They just get the software, they download it, or they get given it to them on a USB key or a DVD, and they load it. And they're going blind. And so thanks to the DHS funding, we realized what was needed is what was some way of brokering information, getting all that information together. And we came up with the platform called FACT, Framework for Analysis and Coordinated Trust. This is a vendor agnostic system for just brokering information from as many sources as possible. Think of it as a bit like a credit score or a trust score for firmware. If you go to the bank and you say, I want to borrow some money, the bank doesn't phone every credit card company. They don't go and check all the other banks. They go to somebody like Fair Isaac or Equifax and say, could you give me a report? This guy's asking for money. Do we loan it to him? And that's what we need for software and firmware we're using in our control systems, is a quick, easy to understand report. Okay, so who would this impact? Who's this useful for? Well, obviously the asset owner. People who are having to load that software into their live systems and may have regulatory compliance issues like NERC CIP 13 and CIP 10. Obviously the vendors, this is important for the vendors to help them manage their vulnerabilities and help understand what's concerning their customers. But anybody who's an integrator or consultant needs this information. If you're installing a new system or if you're doing incident response work on a site, you want to know too what those packages are. And lastly, all the security partners, all the players in this industry who have tools or platforms for security also need to know this information. I want to be really clear. I'm going to show you in a second here a little quick website, but really what I see this as is a series of APIs and capabilities to allow anybody with the ability to detect software in an ICS to get a report on what that software is. So it could be coming from network traffic scanning tools, and there's some great ones out there, anomaly detection tools, tools watching databases, anywhere you can find some software, you can get a report on it. I'll show you two quick examples, and then I'm going to show you an actual case history from one of the players in the industry who is now using this tool. So here's a technician. He wants to know whether he should use that particular binary. It's unsigned. How does he know? Well, by throwing it into fact, he can see that it was actually part of a distribution package that was signed by Rockwell a few years ago. So that ability to build that understanding, in contrast, here's a package with exactly the same name, but it was never distributed by Rockwell, therefore it shouldn't be trusted. I'll give you an example on the vulnerability side. Here's a package that gets a very low score. It's a protection and control manager for substation protection relays. Why does it? Because it's got these vulnerabilities from third parties that are hidden inside it. And you can look at all the details and you can go and drill into the CVEs. I'll give you now, I'll just close with a really good example of a use case. And I don't know how many of you know about the new SCADAwall product from Bayshore, but it's just a really exciting product as a new style of data diode that's very, very high performance and low effort to install. And I'm pretty excited about it. But like all products, it's got firmware and software in there. And so Bayshore approached us and talked to us about the ability to make sure that whatever their customers download off their website can be validated. And so we set up the capability for Bayshore to give a free service to their customers where they can take any software they download or get in whatever fashion they get it from Bayshore, and they can send it out and get it validated before they install it. And this has all been looked after by Bayshore. It's absolutely free for anybody who is using this equipment. Any of their customers get this for free. So it's pretty powerful, and it really helps address these demands for, if you're in the power industry, SIP 13 and SIP 10 requirements. So you have to be able to validate the integrity and authenticity of any software you're loading into your bulk energy system. But everybody should be doing that, whether it's a regulatory requirement or not. So just I'm going to close and then take some questions here. This is a completely platform and vendor independent solution for securing your supply chain. We're not doing anything that is wildly different cryptographic technologies. These are classic cryptographic technologies built together to aggregate information. It's really designed to be built into your processes. Vendors, asset owners, they maintain control of their own software. We don't have, for example, the Bayshore software. All we have is the metadata around that software so you can validate it quickly. And of course, this is designed exactly to deal with anybody who has SIP 13 or SIP 10 compliance requirements. It's free to use in the basic form. So come on, join if you're a vendor or if you're an end user or you're a consultant, head over and give it a try. And at that, I'm going to, I guess, take questions at this point.
Thanks.
Over to you,
Eric.
Dragos.
Yes, thanks a lot, Eric. Really nice presentation. I think it's a really interesting product. Let me see if there are any questions. I don't think for now there are any questions, but I can at least share. Okay, the first one from Virginia, right. Eric, does your third-party vulnerability alert analyze the reachability of the vulnerabilities within third-party component, or does it just alert to the fact of their inclusion?
At this point, the data we're aggregating is just their inclusion. We'd like to eventually add that. I mean, this is intended to be an extensible platform. So down the road, we'd like to analyze reachability, but at this point, it's just, hey, here's a component, it has the following vulnerabilities. You need to be aware of them.
Thanks,
Okay.
Eric. We have another one for you. Oh, the questions are popping up, so that's
Hey,
good.
great.
Seems it was interesting. So next one, what is the challenge in OT security transition for industrial customer?
Wow, I don't know what to. That's a big question. You know, that's a massive question. I believe probably the biggest challenge that people are facing today is that they're dealing with systems that are used in, you know, they're mission critical systems. They're not IT systems, and yet they got tons of IT components and IT capabilities. And we've got this really interesting blend of IT technologies in an OT environment. I think that's probably the big challenge that most people are facing right now, is trying to get their heads around, you know, and what we're doing, for example, in here is exactly this. This is not an IT problem, it's an OT problem. And yet it has got tons and tons of IT components that we need to address.
Thanks, Eric. Another one from Kashif. So while dealing secrecy on application level, what do you say about hardware on which the application is running on?
Great question. What about the actual hardware? At this point, we do not have a module for doing hardware analysis. Again, I'm intending this as sort of a platform for people to do add-ons. So hopefully we can deal with hardware in the future. At this point, I'm pretty busy just dealing with software, firmware, and we're going to start dealing also with documents pretty soon as well, because falsified documents or even documents can contain malware. But at this hardware's down the road. If anybody has any good products or cool solutions that would like to integrate in for hardware, let me know.
Thanks, Eric. Next one. We have another one from Johan. So Eric, are you using the software bill of materials work by NTIA?
Yes, this is Alan Friedman's group, and we're using some of the components. We've had a lot of discussions with the NTIA software bill of materials, and you'll see us using lots of software bill of materials techniques. What we're waiting for right now is the NTIA to finalize and standardize their basically their taxonomies, and then we'll just roll that right in. Definitely my intention is, as that evolves, we see it as a core component. While we're waiting for it to evolve, we've been doing tons of work on software bill of materials analysis.
Thanks, Eric. Another one from Praveen. What are the checklists, the framework, I guess, FACT follows in order to find vulnerabilities? If you can share some insights here.
Yeah, wow. So that's really interesting. And that has been a very interesting artificial intelligence, data science problem. And we actually do a number of different techniques in order to track vulnerabilities in components. First of all, we've got this, go back to Johan's comments earlier about software bill of materials. For every package we analyze, we're breaking out all the components into what we call this software bill of materials. So what are the subcomponents? Then we build a very, very large graph of where those components are used throughout the industry. So go back to that example of the licensing packages from Gemalto. We couldn't find that by searching, say, ABB or Siemens. We found it by searching Gemalto, associating these vulnerabilities back to Gemalto packages that we uncovered. And then by using this tree analysis, we could ripple through and find these packages also in other software bundles and other software installers. So it was to find it once and then you find it all over the place. We've now also using a lot of artificial intelligence, and we just actually had a large project at the University of British Columbia which reads through vulnerability notices and tries to discern sort of the hidden information in them using AI and then associate it back. So somebody may put out, say, a notice, say one of the PLC or DCS vendors puts out a notice that says we've got this vulnerability, and by doing an analysis of that, we can often point back into what products that would actually impact. So a good example would be the Ripple vulnerabilities that came out last week. What we need to do is be able to search down through those bill of materials and say, okay, well, looking for Ripple isn't going to help. Nobody's listing their product as Ripple, but Trek was actually the company that built the software. So therefore, can we find markers that point out where Trek exists in the software bill of materials? So it's a quite a complex project and something we're still working on, and still needs a fair amount of human intervention. Often the vendors themselves are helping us on this.
Thanks, Eric. Great answer. I think two or three more questions. So another one, for ICS vendors partnering with AWS and getting added to FACT, what extra development effort is involved?
Very, very little. I mean, I was an ICS vendor when I was at Belden, of course, and at Tofino. So I know that any poor vendor is just absolutely, their development team is flattened. So we worked very closely with the very first major vendor, which was OSIsoft and Brian Owen, to make this exceedingly low impact for the vendors and zero cost. Because ultimately, it's the vendors who know the most about those packages. So we give them tools that they can plug into their build chain to automatically detect new software that they're releasing. We can give them tools that will analyze what's actually being put up on their website. And basically, it's all automated. What is needed is somebody on their staff to just go in and validate that what we've covered actually actually is, if we find a package and say, hey, are you releasing that? We want them to say, yes, we really are releasing that. Great.
Thanks.
Yeah.
Please. So another one from Paul. Does this give us the opportunity to get a handle of open source software included in builds?
Yes, absolutely. Absolutely. This is, that's the whole intent, is that it doesn't matter whether it's open source or closed source. We want to understand what those components are, because every piece of software has some vulnerabilities or has the capability. So yes, this will give you an analysis. So actually, we're working with another large company right now and specifically helping them uncover open source vulnerabilities in their packages.
Perfect. I think we have still 2 more minutes to go through some questions. So another one from Danny. What is done to prevent FACT from being poisoned with malicious data?
Well, I only have 2 minutes, so I can't go through the whole list, but a lot. And in fact, the Department of Homeland Security has hired a red team / penetration team. They're currently trying to do exactly that as we speak right now. They've been attacking our system now for over a month. They're definitely finding things that we need to correct, and we're correcting them as we go. But we're doing a lot of things to validate the information that's being sent to us by the vendors. Only vendors can submit stuff. It has to come from within their development organization. We have a pile of checks and balances using cryptographic techniques. So that's a long answer, but just the quick answer, and I can go into this in more detail personally if you want to contact me, is that we're currently having that very carefully checked by the Department of Homeland Security's Red Team group.
Okay, one last question, Eric. One last question from Praveen. How frequently this framework is updated for vulnerabilities? Can this be fine-tuned?
Yes, the answer is yes. Right now, we're probably checking the vulnerabilities about once a week, maybe once every 2 weeks. Our goal is to bring that down tighter and tighter, and then allow our corporate customers to actually get daily reports about what new vulnerabilities are in software that we've seen them actually using. So that they can say, hey, this package was actually spotted on this network in this plant, and it has this new vulnerability today. So we can get very, very fine-grained vulnerability reporting. And again, the intent is to make this so that people aren't just buried with vulnerability notices, but rather they're getting timely vulnerability notices for the software that is actually being used in a particular facility.
Thanks a lot, Eric. There are still a couple of more questions, but please reply to them offline. I think the time is up. Thanks a lot for your topic, Eric, and it was really interesting. I hope also the audience liked the topic. I guess so, based on the number of questions you received. Next, we are going to have Joe, who is going to talk about the road to industrial IoT security. And just to present a couple of things about Joe. So Joe Malenfant is the director of the IoT marketing at Cisco. Joe leads the company's efforts in basically defining marketing voice within the Internet of Things space. I guess everyone knows Cisco. So it also provides clarity to prospects, customers, and also their partners. Joe has over 10+ years of leadership experience driving innovation in security, services, information technology, and of course, Internet of Things. Joe has also experienced launching category-defining products, pure play software as a service, hardware solution, both in IT and OT environments, and this proved critical, were proved to be critical in driving the industrial IoT, and digital transformation initiatives at Cisco. Joe, the stage is yours. Thanks for being here.
Awesome. Thanks a lot, Dragos. And thank you, Eric. That was really awesome to hear a lot more around the supply chain attacks and basically code certs. It's amazing to see where we've come from over the last 10 years. So as Dragos mentioned, my name is Joe Malenfant. I lead marketing for Cisco's IoT business. I've been in security for more than the last decade. It's an honor to actually just be able to go right behind Eric because you know, I have listened to Eric. I've been to conferences where he's presented. I have presented alongside him in the past. So, and hey, here we are again. I've been in the IoT business for the last about 18 months with Cisco. And previous to that was leading endpoint security within Cisco. Prior to Cisco, though, I was with this small startup in the industrial control system space that some of you might have heard of called Industrial Defender. We were eventually acquired by Lockheed Martin, and I think it's had a bit of a sordid history since then. Now, Cisco's coming onto this IIoT world presentation, and some of you are probably thinking, why is Cisco in the industrial space? You're a networking company. Truth is, we've been in the space for a long time. Long enough, in fact, that we've been recognized as a market leader for industrial edge networking components, including managed layer 2 and layer 3 switches, routers, as well as wireless access points. Because yes, the industrial network also requires networking equipment and knowledge today more than ever, right? Because we're really at the point where these two worlds are converging. And that means that IT and the OT sides of the house are coming together. I've been around the space long enough to know that this is also the slowest convergence in history. I think 12 years ago, somebody was like, this is happening really fast. And I'm like, now it's 12 years later and it's still happening. So it's not necessarily the convergence. And as much as sometimes we want to call it a convergence, it's not. It's really the fact that we're creating a partnership. And so for Cisco, we spend a lot of time being translators for both sides of the table. We're explaining the mission critical role of the network and the criticality of the operational environment all at the same time. But without fail, in every conversation, security is absolutely a top driver for an IIoT project. And frequently, it's bringing the IT and the OT teams into the same conversation. Both parties ultimately are really driving to the same end goal, but have differing priorities for how they get there. One side cares about service delivery, and the other side cares about how fast an email gets delivered and to ensure network stays up and running. And that's why whenever you're bringing these two sides to the table, context is really so critical. I don't know about you guys, but if you've ever mentioned IED around a group of IT professionals, they think you're about to recount some sort of war story instead of referring to an intelligent electronic device. Similarly, if I say rat to a group of operations professionals, it'll likely conjure up an image of a four-legged animal. in the last 12 years that I've been working with both the IT and OT teams, today looks really different from back then, when the idea of passively monitoring a control systems network for potential threats was a challenge, because most thought there was no issue, right? You may as well just bury your head in the sand and say, that doesn't actually exist. And for the record, no, I will not have a slide with all of the top headlines and the bad stuff that's happening all over the world, because if you didn't think it was a problem, you wouldn't be sitting on this Zoom call today. So what it comes down to between bringing both of these teams together is that context is critical, so that they both understand and really what it is, so that if I do mention RAT, we understand it's a remote access Trojan and that you need to pay attention to it immediately. But the biggest challenge is finding out, what do you even have? What do you need to pay attention to? You need to have that accurate asset inventory. And this is foundational, because the old adage stands today: if you can't see it, you can't protect it. I can tell you that over the course of more than 300 assessments during my time at, in the earlier part of my career, every single organization said they're air gapped. Unfortunately, they didn't really understand what the term air gap meant, because we could find a direct connection to the internet. On average, we actually found 11 direct connections to the internet. Only once did we ever find an instance where somebody was truly air gapped, and they were on an island and they were not American. So that's when you start to find out that, hey, we are connected. There's a reason Shodan exists, right? And what was even more interesting is that you would find these configuration changes, and that most didn't actually understand how something was configured. So when something was changed, whether it was expected or not, the cascading effects of that change was pretty interesting. Fast forward to now, not the COVID era now, but just the here and now, the interconnectivity between IT and OT that is being driven by the need for more data, right? We're data monsters. What I've seen is that every single connectivity project really starts with an outcome. It could be improving predictive maintenance on the robots in the factory, reducing congestion in a city, or improving worker safety by automating operations in any hazardous environment, whether that's, you know, something like underground mining or in a oil refinery. In order to get the outcome you need to get the analytics to make a decision. To make that analytics successful, you need to get data, but to get data, you need to have pervasive connectivity everywhere. In order to connect everything, you need to actually have it connected to a robust network. So this is why the network is so foundational to all these projects. Yes, there are different protocols. Yes, there are different connection types. Yes, there's different assets. And yes, we can address all those. So let me paint the picture with a little bit more of something that we're all going to understand, right? I'm going to use a real life situation. In this case, it's an automotive manufacturer who's having lots of unplanned downtime due to misconfigured assets. They had a mix of protocols across the plant floor, and there was no real visibility into the networking equipment, even from the management side. And the lack of any standardization made troubleshooting darn near impossible. So they decided to standardize on Cisco for their operations network, because we could support the protocols that they were actually using. We could provide them with automated asset visibility and get to the level of threat detection that they actually wanted, and allow the operations team to leverage the expertise of the IT team to manage the network. And because we can monitor the network traffic directly from the infrastructure, there's no need to drop in an additional box that comes from who knows where, if you think back to one of those instances where Eric was talking about supply chain attacks. We've reduced the downtime because they don't need to roll a truck or get a third-party contractor to come in, and that's an issue because it's the same tools that the IT team already knows. Okay, but the question has to come down to, right, that's a great case study. How did you actually get there? There was 4 steps to this process. And from here, I'm going to start with the why, the what, and the how, right? So first, with a view of the network traffic, it's easy to identify when something anomalous occurs. If you understand what you're looking at, that is. Thankfully, we do. We understand how to move packets. We understand what those packets actually mean. Now, we have had a significant presence in the network, in the industrial network, that is, for the last 20 years. Someone say, wait a second, what do you know about industrial control system cybersecurity? Great question. So last year we went and acquired a small company out of France called Centrio that was they basically built a software sensor for industrial control system cybersecurity that could decrypt all of the protocols and do the analysis. Because it's software center, that actually allowed us to deploy it directly onto the infrastructure, routers, switches, and access points, the stuff that is moving all those packets around. This allows us to see all the traffic, allows us to discover all of the assets and map the communication patterns that occur between the machines, as well as anything that might be happening outside of the network. Now that we've identified those assets, the ones that this manufacturing facility actually had, they're able to group the assets and define the right security policy for each. For example, PLCs shouldn't be talking to other PLCs, or they should be not talking over certain ports. Now that we have an accurate asset inventory, we've defined the security policies for the assets, we start to segment the network. We're not getting granular at this point, but instead it was as simple as keeping the paint line from communicating with the robotic welding line. Segmentation was a game changer in this particular instance and in every other one, but really for two big reasons. First, it allowed them to mitigate the risk of lateral movement and propagation of threats without having to put in any bulky or noisy security solutions. Second, they were able to pull in the IT team and leverage the expertise as they had already done the segmentation work on the corporate network. Now, while this is a four-step journey, things don't just go in this linear fashion, right? It tends to be in a little bit more of a, we're gonna try this and we're gonna work on this at the same time. So while segmentation was being implemented, this particular organization also leveraged the deep packet inspection capabilities from CyberVision. That's the name of the product from the company that we acquired, Centrio. So it's called Cisco CyberVision. That's what they deployed to identify the assets in order to find the existing problems. So as I mentioned in the previous slide, we found a number of misconfigurations that were causing issues, but we also found some malicious code, malware that was actually embedded in the controllers. Back to the supply chain attack thing, right? Now this level of information really led them to start down the path of an integrated IT/OT security operations team. As I mentioned earlier, it's a partnership. A control systems engineer can't expect a security analyst to understand process optimization, just like the analyst can't expect the engineer to perform dynamic malware analysis. Now, I know there's more than just a few out there that at one point or another are part of a segmentation project, or even the term can make you probably want to go to your happy place, right? Historically, it has been relatively complicated. Thankfully, we've really simplified it and made it a lot easier because we've embedded it as part of the networking infrastructure. So I talked about the automobile manufacturer and what their process was, but now the question comes down to how, right? How do you make it actually easy? And because it started with the network at the very bottom here, right? They leveraged their infrastructure. That's everything from the switches and the routers that actually move information that connect it all together so that they could actually gain the visibility. The network is what gives them the visibility. And then it moved up from the left side. From the network, they put the software sensor on to say, what do we actually have connected in here? Who's it talking to? And then lastly, they're actually able to enforce the segmentation. So once they knew the assets, they're actually able to turn around, put the PLCs into one group, put other components into a different group, and then segment different parts of the network, both from plant A to plant B to within the specific plant itself. Earlier this year, we actually saw quite a few instances of ECAN's ransomware not totally destroy an operation network either due to segmentation. They were actually able to contain it to where it got in. So let me leave you just with a few key points here before we close out. One, when IT and OT actually partner together, good things will happen, right? And a lot of times what we're seeing right now is that's being driven by the security conversation. Number two is if you want to build a security program, having a good handle on your assets, what needs to be protected is really paramount. And when you partner with IT, the context will become the differentiating factor because that is what makes things meaningful. Third, and it's a pretty basic step, but it's to define security policies for these assets. PLCs don't need to talk to other PLCs. I think I've said that 2 other times now. Pretty simple, pretty straightforward. We can enforce that. And then lastly, you need to enforce it, right? That's the last step, is the segmentation. It's easier to think when you really have that right network in place. Okay, that's it for me. I'm going to stick around for some questions. If anyone has any additional questions, I'll be happy to answer them here live. We can connect on LinkedIn. Feel free to email me for anything else. And check out cisco.com/IoT for everything we just talked about and a heck of a lot more.
Thanks a lot, Joe. Really enjoyed your session. We have so far, so please pop in if there are additional questions. I will start with the first one. You mentioned identifying assets. Don't clients have to prioritize them as well?
So I think it comes down to number one is having a good handle on what you actually have. What we frequently get to see is when you walk into an operations environment, it's what assets do you actually have in here? And whether it's, there's lots of information on surveys, most people don't have an accurate asset inventory, more than half, just don't know what you actually have. I remember there was one time we actually found a SCADA system underneath a person's desk that was operating part of the electric grid, and that employee had retired 6 months earlier. No one knew it was actually there. So it's important to understand what assets you have, number one, and then you can actually prioritize which ones are the most important to be protecting and how do you actually group and protect those assets. So scope and then prioritize. But yes, prioritization is actually important as well.
Thanks, Joe. Another one, when we integrate IT with OT, where IT has been sensitive to security issues and OT is not, what's your view for integration of these two?
That's, yeah, and it's interesting because that's where, you know, I really lean on the segmentation component, because segmentation doesn't come down as much to a security conversation as much as it can be an access conversation or ensuring that operations is able to run flawlessly. So it tends to not have to become really complicated, not over rotate on the security aspect. Like I said, in my past, it's been threat intelligence and malware analysis, but that's going to fly over a lot of the operations heads. So if you focus on prioritizing and saying, hey, we want to ensure operations is running smoothly, ensuring availability and reliability of the systems, then you're not having a security conversation around, hey, we need to protect everything. We need to put more security controls in place. You focus really on the priorities for the operational side.
Perfect. Thanks a lot. Another one, if asset discovery is the only challenge, what is holding customers back in implementing OT security?
I don't think that asset discovery is the only challenge. I think it's probably the first one that you need to overcome. Once you've got that accurate asset inventory, there's still more work to do, right? You can discover all your assets and have a list. It's a little bit like compliance. If you're in compliance, that's the low water mark. It doesn't mean that you've done your work. Putting antivirus on your Windows machine, is that saying that you're secure? Is having a firewall saying you're secure? In no way, shape, or form is one single step going to be a silver bullet. There is a process to it. So asset discovery and knowing what you need to protect is step one, and that it takes time to actually do it. I think that a lot of organizations have seen over the last 10 years, there's been a lot of, I don't want to call them, there's been a lot of technologies that have come out that have tried to do it. And then when they go to implement it, it's been a lot harder than they ever thought it was to implement. So there's that once bitten, twice shy, or you get burnt by, hey, we tried to do this before and it didn't really work. So asset discovery, what you actually have, is definitely step one.
Thanks a lot, great answer. Another one from Jan, not to talk solutions, but will Cisco extend the intent-based networking concept to ICS networks?
So in a certain sense, we already have. We do have intent-based networking going all the way out to the IoT edge, but it's more from the networking infrastructure components. So if you put in a wireless access point, and by the way, I'm not an IBN intent-based networking expert here, but if you do plug in a wireless access point, for example, to your OT network, then yes, it will fall into your intent-based networking management. So if you're using DNA Center, for example, or something like that. So in short, yes, we do, but I think there's, we might want to discuss it offline. I think you might want to go even deeper into the ICS network than just the network management side of it. And if that's the case, I mean, my email's right there. Feel free to email me.
Thanks. Thanks, Joe. While we'll be waiting for a couple of more questions, I also have a question from my side. What would be the industry that you would think it will require or would have the most focus, security-related focus in the future? And I'm just giving some examples, maybe like automotive or even going to smart cities or any other types of industries or areas which you think that should be of focus for us, security professionals.
Mm-hmm. So I think I'm going to break this down in two ways. One is there's been a number of industries that have actually done a pretty darn good job of protecting their operational environments already, right? So I've got to tip the hat to specialty chemical, for example. They don't publish patents on their specialty chemicals because, oh, look, here's the patented recipe, I can go and copy it. So when you look at somebody producing a chemical, they've had to take a really proactive approach to their chemicals and protecting trade secrets. So anyone with trade secrets or intellectual property has done a pretty good job so far. Specialty chemical manufacturing, especially if you're in the defense manufacturing sector, they've done a pretty good job so far. I think where there's probably more opportunity is utilities, for example. So the electric grid. I was around when the first iteration of NERC SIP came out, and you could see everyone kind of jumped at it, just say, yay, we're secure. But what it was is, again, it's compliance. It's the lowest possible watermark. To be secure, it takes so much more than just reporting on this basic checklist. Again, is your laptop going to be secure if you've got a 10-year-old signature-based antivirus on it? I doubt it, especially if you're connected to the internet. So utilities and any public sector utilities, such as a water utility, likely heavily at risk. Oh, sorry about that.
Thanks, Joe. Let me see. Okay, we do have one more question. Do you consider connected cars as industrial IoT? Does Cisco Security works for connected cars as well?
So connected cars is a multifaceted problem because back to what Eric mentioned earlier, supply chain, right? There's a lot of instrumentation within the vehicle itself. Then there's the communication for over-the-air updates. That one is definitely going to be a bit of a multi-layered approach. We're not going to add or we're not going to embed certain types of security into the vehicle. It's going to have to be security that's baked into the way it's designed, into the code itself. So do I consider Cisco Security working well for connected cars? I think there's a certain aspect of it, especially from the network management side of it. So connected cars, the way that, for example, think of any electric car, think of the most famous electric car out there. It is connected to actually one of Cisco's platforms. And so that platform is used to push over-the-air updates to the software. So if the maker of that car is pushing a new software update, it will use that communication pattern. And then there's an open pathway between the two to gather telemetry and things like that. So there's definitely Cisco Security built into the platform that sits above it that is pushing the new software down to the vehicle, and then the actual encryption between the two. So yes, there is Cisco Security for connected cars as well.
Thanks, Joe. And if I can add to this, because in my work in Accenture, I'm working mainly in automotive security, and I've been working a lot with colleagues from Cisco in this area. So you have really great guys. They're really smart and technical guys. So yeah, I can confirm it on my side from Accenture. Good.
Yeah,
I think
I can't lean into the connected car too much because there's a lot going on there.
Yeah, that's true. Joe, I think that's the time's up. Also for the Q&A. Thanks a lot for your session. Again, very interesting. I really enjoyed it. Hopefully also the audience. Now we are going to move to Ulrich, who is going to talk about the automated ICS vulnerability assessment. And I'm also going to spend a couple of seconds on sharing a couple of interesting things about Ulrich. He received his PhD from the University of Cambridge Computer Laboratory, the security group, on conceptual aspects of middleware security back in 2003, and it was sponsored by the UK Defence and Evaluation Research Agency. He also completed a master's degree in information security from Royal Holloway College, University of London, back in 1997. And he's currently working on an intelligent big data supply chain risk analytic solution and other various projects around policy automation and policy testing. He's also on the board of directors of the Cloud Security Alliance. I think all of us know CSA. And is a technical expert witness. He's also responsible for the development of the Open PMF user interface, policy automation, and testing features. And he also runs the US office in sunny San Diego, California. Thanks for being here, Ulrich. The stage is yours.
Thank you. Great. Welcome, everyone, and thank you for having me. So yeah, I'll be talking about automated ICS vulnerability assessment and some current research work we're doing that we're doing for the government and kind of setting the scene a little bit for people trying to get a handle on what's going on with ICS security and what they got to do about it. So here's the one slide about our company. I guess the intro already said it all. We've been working on security automation for close to 20 years. A lot of it related to security policy, fine-grained access control, and attribute-based access control. So that's where this OpenPMF product came out of. In more recent years, we've worked on supply chain risk analysis automation, especially in a Navy project where we look at IT supply chains, but from the angle from procurement data and shipping data and supplier data and so on. So it's doing this passively versus things like vendor vetting, and also works on microelectronics and boards and parts and so on. The thing that really we're focusing on today is vulnerability assessment and pen testing automation, especially for embedded systems. And that's a government-funded R&D contract. Yeah, I'll be spending a little bit on that. Yeah, I guess I skipped the stuff on the right side since it's already been introduced. And I'll move on to the next slide here. So you look at IIoT cybersecurity, there are many challenges, and I only put a few out there. So one that's a big one is usually there's often outdated vulnerable software on these devices that's literally unpatchable due to whatever, either age or lack of access or lack of network connectivity or manufacturer not giving you access and so on, right? So usually people don't think of these things as having to do regular updates on those devices. At the same time, embedded devices aren't really kind of PLCs, logic controllers anymore. Quite often they're now really full-fledged computers in recent years, and it's going to continue this way. So there's a lot of functionality on those devices, a lot of software and a lot of unused software too. So that makes it really challenging to get a handle on cybersecurity there. Yeah, I guess there's lack of risk assessment and risk management knowledge for IIoT, especially for embedded systems. What I mean, for example, is we have pretty well-established libraries like CVS, the Common Vulnerability Enumeration libraries for normal enterprise software and systems. We don't really have those so much for embedded systems. That's a really challenging situation that basically the standard, if you will, if you sum it up, the standard way for the cybersecurity industry to assess vulnerabilities doesn't directly translate the tools, and the knowledge doesn't directly translate to IIoT, unfortunately. So that's really a problem. And then I guess the physical access to the hardware is a cybersecurity issue in the sense that if I can grab the device and open the device, I can potentially get a lot of stuff, to more stuff than a hacker would be remotely on your whatever servers and so on, which they can on embedded devices too if they have network connectivity. So there's a lot of problems there. What we often see too is weak encryption compared to like laptops and so on, or computers, full-fledged servers, due to, especially in older devices, due to the limited resources that are like as in processing power, memory, and so on those devices. And then monitoring is often not really timely, or isn't even there at all if devices are essentially put somewhere and left. You know, quite often you don't have the connectivity to really do some real-time monitoring on this. So anyways, the list would go on for a long time, and I'm stopping here, but it's a huge topic. So there's a lot of problems, and a lot of companies are resolving those. So it's not like it's all doom and gloom. But I think what's really important is that IIoT, and especially embedded systems, there are a kind of different space from traditional, if you will, computing, like enterprise kind of normal computer computing, right, or server based. So that is just important for, I guess, the cybersecurity community to understand. So one of the questions that we've been tasked to look at was, well, how to check if IIoT devices are vulnerable? You know, so there's many ways of doing it, and we already had a presentation earlier, and we do something else, and I think there's a combination of many things that need to be done. But like the challenges in order to check this, whether your device that you may have already deployed years ago and not updated is vulnerable or not, it's challenging because often they're already deployed, right? So they're already on some, say, well, we're dealing with the government, so on a ship, for example, they would be deployed on a ship already, and you know they're there, but you don't know, you know, it's not like you can just unplug them and take them home and analyze them, you know. So often they're like actually truly embedded in a device, you know. There's often no screen or keyboard, but the only way to interact is through either a console terminal type thing where you plug in, or through a diagnostics port like UART or JTAG or other ports that the manufacturer put in for diagnostics. They're often proprietary in their nature, as far as what they communicate with you. Logins are often unknown. So we've seen this, for example, in medical devices, where they either default, so everyone knows them and you can get them on Shodan, or they're unknown and only the manufacturer will use them for their own servicing. So you will not be able to get in unless you break in. And device internals are often unknown. So quite challenging. So how is it done today? In our experience, it's basically people doing it. People go plug in, break into the device, extract the firmware, analyze it, and create a report. These people are scarce, expensive, and yeah, there's just not enough talent out there, you know. So our research question was, can this be done simpler and cheaper, especially for devices that are already deployed? And what we're developing is called VAPT. VAPT stands for Vulnerability Assessment and Pen Testing, and it's supposed to be an automated VAPT, like Vulnerability Assessor and Pen Tester. So basically a portable device that non-experts can connect to IIoT devices already deployed in the field. The device then, if you will, breaks in, extracts and analyzes the firmware, and provides an an easy to understand result. One of the that's already all pretty challenging to build, but one interesting aspect of the use case is that we use deep learning to predict and learn over time what works and what doesn't work, kind of like one of those human assessors. As they get more mature in their career, they learn kind of sequences of things that work and don't work. So that's we already built quite a bit of this. So this is a working advanced running prototype, and we got several years to go in this project to get it to a stage where it's going to be polished, basically. I think there's what I want to focus on is there's multiple ways of getting into a device, because that's really where it's all different from the usual software analysis, where you provide your binaries or you install an agent or whatever, right? Here, the question is, how do you even get in, right? So device ports are usually, you got things like USB and sometimes memory card, like SD card slots and so on the exterior, and network, obviously, which I'm going to come to later. But you also have internal ports on the board, like UART and JTAG, that are serial ports, and these can be used. Sometimes they reveal a console for you, right? So the BAP box, in this mode, if you will, probes ports, so you can plug it into the diagnostics ports on the board, and executes a sequence of actions. The actual assessment actions, once it's able to extract the firmware, they're in our case, they're using mostly open source vulnerability assessment, binary vulnerability assessment tools. They're being encapsulated in containers, and we run those, and they're basically not easy to, not intended for automation. So they're meant as tools for experts. So the kind of output you get from those tools is intended to be native to the tool and understood by an expert as part of their analysis. So one of our main pieces of work was to map all this output back into a common nomenclature. In fact, we use CWE and not CVE for the reason that CVEs don't really seem to exist very much for embedded devices. So a CWE, common weakness enumeration, is the basis, if you will, the metadata of a CVE. So a CVE talks about a vulnerability for a specific kind of software version, for example, and it has an underlying weakness that it pertains to. So say a weakness for a specific, say, Apache server version or something like that, right? The underlying weakness is independent of the specific technology. So it would be something like unbounded string, unchecked string copy, buffer overflow risk, or something like that, right? So we map to CWE, and then we essentially run analysis over the bulk of tools. A real challenge here is that our device is supposed to be a battery-powered offline device that you can bring to the embedded system. So this is where it's really radically different from most other technologies out there, because that limits dramatically what you can do. Things like dynamic binary code analysis, binary analysis, they take usually a long time. They take a lot of processing power. So you only have a certain time before you run out of battery or out of time before, and then you gotta find a result. So it's a pretty specific use case. The reports also are supposed to be for non-experts. I mean, think of a fancy traffic light score, right? And then when the device has connectivity back, it goes back to a backend and everything gets analyzed and the AI runs and so on. So this is really the hard piece here. And frankly, even breaking into a device, especially if it's at the military or government, is relatively challenging because these ports are often tamper-proof. So you can't just run your pen test on a diagnostics port; it'll lock you out. So we do have a bunch of remaining challenges there. But for commercial off-the-shelf, this works pretty well by now. Via networks, it's easier. We've actually done some R&D before that for also a different government agency. kind of follows the same idea that I've described, but instead of having to plug in anywhere, you just sit on the same network. And in a way, it uses, for the cybersecurity crowd here, it uses everything that Kali Linux can do, but automated, right? So there's a bunch of there are a bunch of people out there that have done this kind of network-based automated pen testing. It works better or worse depending. So we got that working too, and it's actually way easier than the vulnerability assessment, because all you do is probe, well, port scan and do things like that, right? Nmap, port scan, and also on the network, the CVEs apply, because a lot of the stuff that's on the network from an embedded system would be things like a web server for your admin console, for example, and that uses standard components usually, like a lightweight web server of some sort. But same flow, if you will. And I'll leave it at there, because I'm sure there will be questions. We do have a demo video online. The whole thing's really in a way a collaboration, because we're talking to many vendors in the space and many open source teams that provide vulnerability assessment. There are literally hundreds of tools out there, and some better supported than others, and some overlapping in scope, and some adding to each other's scope, and so on. So it's a majorly challenging space, as also evidenced by the DARPA Grand Challenge that happened a couple of years ago, where several teams showed up in, I think it was Vegas, with data, each kind of a rack-mounted data center on stage, and ran through a bunch of binaries to figure out who can find most vulnerabilities in the shortest time. Now, that we use some of those software components, but that's kind of easier if you have a data center. It's extremely challenging once you have a portable device. And portable here, by the way, means briefcase size or something like that. It does not mean iPhone size, you know. So we just want to make clear there's probably no way to really assess the binary without external knowledge, and we were supposed to do this without signatures, without software bomb, without any prior knowledge of the device, basically. So that drives up CPU and requirements and memory requirements substantially. So these sound like mundane challenges, okay, dealing with performance and so on, but they do matter critically when you do vulnerability assessment. And that's me. Here's my email. You can find me on LinkedIn too, and I'd love to discuss it more. And I don't know if we have time for Q&A.
Yes, we do. Thanks a lot, Ulrich. Really interesting. Let's start with the questions that popped up. What is missing in the current OT security solutions available in the market? So basically, what's the differentiator, I guess, of VAPT box?
Yeah, so like I said, typically you don't have a portable device that you can bring to the embedded device that can run battery powered without any prior knowledge of the embedded device, and in many cases give you a result. That's really the big differentiator. Now, if you have access to your firmware, then you unlock and you can go to numerous other solutions. But if you don't have access, getting the assessment to the device versus the other way around is one of the big differentiators. Also, looking at these tools out there, you do have to have a level of expertise in order to make those work for embedded systems. So, you know, you can use, there are many tools like anything from, well, I don't know, Anger to AFL to, you know, I don't know if people know those tools. I'm just throwing out a few buzzwords, but these are open source tools for vulnerability assessment that really require an expert to operate. So to automate those, it's really there's a gap in the market at this point. I think all solutions that look at binaries that we're aware of, they are usually SaaS based, and usually based more for enterprise type CVEs. They're very good at taking your Unix binaries or Windows binaries or whatever it is and analyzing very, very elaborate great analysis. So this is kind of a niche, IIoT embedded niche issue here. Should also explain maybe the use case for our customer is to be on a ship that essentially may not have internet connectivity or may lose internet connectivity while you're keeping this offline service, offline box running to analyze stuff. So it's a pretty stringent use case.
Thanks a lot. Thanks a lot, Ulrich. And if there are any additional questions, please answer to them offline. We will jump to our next speaker. We are going to let Jack Marshall speak, and he will be talking to us about analyzing and preventing ICS attacks with the MITRE Matrix attack. So a couple of things about Jack. He is a senior director of product marketing at Armis. He has an extensive background in enterprise security, including specialization in endpoint security, network security, and IoT security. Prior to joining Armis, Jack held senior marketing position at Cloud Passage, Forescout, McAfee, and Trend Micro. Marshall also graduated magna cum laude from Tulane University, where he studied engineering and business. Jack, it's a pleasure to have you. The stage is yours.
All right, thank you, Dragos, and hello, everyone. When I was thinking about today's conference, planning my talk, I thought that this audience would really benefit from a discussion of a really great free tool that's now available to help you analyze and prevent attacks on industrial control systems. And the name of that tool is MITRE Attack for ICS. And now the question, yes, I can fast forward the slides, great. So let's just dive in. First, who is MITRE? Well, MITRE is a not-for-profit organization that works in the public interest. They work across federal, state, and local governments, also across industry and in academic environments. And they started working on cybersecurity in 2015. Now, ATTACK is a knowledge base created by MITRE of adversary behavior. It's based on real-world observations of how attackers actually have broken into enterprise environments. This knowledge base is free for everyone to use. It's community-based. And in fact, my company has worked with MITRE on the most recent attack matrix, the one for ICS. Now, the important thing to you is that ATTACK is a very useful tool that can help you assess your existing ICS security. Now, if you go to attack.mitre.org, you'll see this. You'll see that they've actually published several different attack knowledge bases. They published 4 knowledge bases for enterprise operating systems, Windows, Mac OS, Linux, and cloud operating systems. They published 2 attack knowledge bases for mobile operating systems. And then just this past January, they published one for industrial control systems. Now, even though you might be trying to secure an ICS environment, the fact is all the various attack models are actually useful. And let me show you why. If you look at the Purdue model, you see that the upper layers are comprised of enterprise systems, and they're running, Windows, Linux, and so forth. And the lower layers are OT environments, which might be running different operating systems. Now, the truth is that most attacks on OT environments start in the enterprise layers and then move down to the OT layers. So the enterprise attack model is really an important tool for you to be able to understand attacks coming from the upper layers. But once the attacker reaches the OT environment, he needs to target the unique operating systems, the embedded systems, the different kinds of communication protocols. And that's where the attack for ICS model comes in handy. So now that I've given you some context about what MITRE attack is, let's focus specifically on attack for ICS. That's what's new. That's what was just published in January. Now, the attack for an ICS knowledge base is broken up into 11 columns as shown here. And each column represents what MITRE calls a tactic, which is a technical goal that the attacker has. For example, the first tactic is called initial access. Now, the attacker can choose several different ways to achieve each tactic, and each method is called a technique. So you see in the first column, there are 10 different techniques. And overall, there are 81 techniques in the MITRE ATT&CK for ICS knowledge base. So now let's break it down further. The first 8 tactics are about finding targets and collecting information and eventually staging an attack on the ICS environment. Once that has been accomplished, the adversary moves on to the next 2 tactics in which he's trying to really directly affect and attack your industrial control system. And then the final goal is to create an impact on your environment, such as damaging property, denying you the ability to control your OT environment, impacting your company's revenue, et cetera. So one interesting thing you can do with the MITRE ATT&CK knowledge base is to emulate an adversary. Now, this is essentially a threat-based red team exercise, and it's really thinking about what techniques are most likely to affect your environment. And you can implement this attack in a non-production environment and get a good idea about what data sources you would need to collect and what kind of analytics would you need in order to identify such an attack. And this is a really good exercise to assess your current defenses. Now, I want to talk to you about a practical example tied to just one of these attack techniques. It's a technique that can be found on the left side of the attack matrix. It's called Internet Accessible Devices. MITRE describes this technique as shown here. They say that adversaries may gain access into industrial environments directly through systems exposed to the internet for remote access rather than through external remote services. Minimal protections provided by these devices, such as password authentication, may be targeted and compromised. Now, everyone loves a good story, so let me tell you a real-world story about this technique. One very large manufacturer we were working with was interested in testing Armis's product, and they told us that they had a rock-solid implementation of the Purdue reference architecture. They said that they'd installed jump boxes in their DMZ, and these were for the purpose of allowing third parties to remotely access their OT environment for remote maintenance of the environment. And they swore to us none of their OT devices had internet access. So we said, fine, great, good to hear. And then we installed our software, which monitors communication in the network. Well, within the first day, we saw devices in the OT environment that were communicating directly with the internet. I think Joe mentioned this previously, a gentleman from Cisco, that as a rule, these OT environments are exposed to the internet. It's very common for us to see that a firewall has been misconfigured to allow this kind of communication. How does this happen? Requests come into your security team or to the operations team to open up the firewall just to enable some maintenance or some data acquisition, but it's done improperly or the configuration is not reverted when the maintenance is complete. So that's my story. And now let's take a deeper look at the MITRE ATT&CK technique that's known as T883 Internet Accessible Device. So what MITRE is talking about here is an attacker accessing your industrial control system. And in our experience, the problem areas for you to be concerned about, there's a few of them. First is configuration errors, like I just talked about. It's usually firewalls that have been disabled, or maybe the firewall configuration might be too permissive. A second problem is unknown loopholes in different security architecture elements and network infrastructure elements. A third problem for you to be aware of is Shodan. Now, what is Shodan? Well, in a nutshell, Shodan is a search engine for devices. It's open, it's free, it allows you or an attacker to find all devices that are open to the internet, and basically it's like the easy button for attackers. Now, if you've never looked at Shodan, here's what it looks like. And look, ladies and gentlemen, look what Shodan conveniently includes right on the home page. It lets you click on Internet Industrial Control Systems. It lets you see what's available. I'm not making this up. And if you click that button, you come to this page, and here Shodan conveniently lets you pick which brand of industrial control system you want to attack. You can pick which ICS protocol you want to attack. And you click on one of those buttons, one of those protocols. Let me back up. Thank you. And Shodan shows you a breakdown, by country and by organization. It looks like here, as of 3 days ago when I put this presentation together, looks like Verizon Wireless has 1,666 devices that you or they can access over the internet. So back to the problem areas. The fourth problem area is vulnerabilities, because it's not only about access to devices, it's also about whether the attacker can compromise your ICS environment. Now, one case in point is Urgent 11. Urgent 11 is some research that was done by Armis. It's a set of 11 vulnerabilities that allow remote takeover of industrial devices because of vulnerabilities that exist in the networking stack. So those were some common risks. And now, what are some practical defenses you can use? I'll give you just a few ideas. First, as one of the speakers said before, you have to know what devices you have. You need a strong asset inventory. You need to know what you have so that you know what you need to protect. Now, in industrial environments, there are usually some great engineering printouts of what devices exist, but a lot of times there's a lack of understanding about how they're connected. And your asset inventory really needs to go beyond just OT devices. It really should include all the devices in your environment, and that includes IT devices like security cameras and badge readers, HVAC systems, etc., because all of these devices can be used as an attack vector against your industrial control system. Practical defense number 2 is being able to monitor connections. You need to know what connections each device should make, and you need to monitor these connections. And these are just fundamentals. If you don't know what connections to expect, then you can't detect communication anomalies. The communications should be very predictable. Now, this chart is an example of knowing what to expect. If you're doing all of this manually, then basically you need to write all this down. If you invest in an automated system, it might be using machine learning or artificial intelligence, and that makes your job a lot easier. Practical defense number 3 is to be aware of your vulnerabilities. I mentioned before, Urgent 11 is one important vulnerability to be aware of. And many manufacturers of industrial equipment have announced that some of their equipment is vulnerable to Urgent 11 attacks. And of course, there are many different vulnerabilities. Now, if you have an automated system that could allow you to perform a risk assessment for each of your industrial devices, it really helps. Now, in this example I'm showing here, the ICS device exhibits 2 CVEs as shown on the top of the screen. One looks like it was from 2016, another from 2018. It looks like the device is also vulnerable to Urgent 11. If you look at the device manufacturer, he has a good reputation, and the device model has a good reputation. And then you see in the lower right, you see that the device is connecting to 2 different networks, the OT network and the corporate network, and that's not something you want. So when you look at all of this, you might score that device like a 9 out of 10. And this is useful so that you can prioritize your risk mitigation efforts. Okay. Practical defense number 4 is automated detection and response. So what could that look like? Well, here's one quick example. For example, being able to detect Shodan scans. This is something that Armis detected. We happen to know that an IP address 66.240.205.34 is associated with Shodan scanner. Another example, in this case, we detected MITRE attack technique number T818, which is named Engineering Workstation Compromise. We saw suspicious network traffic coming from a device. So it's also helpful if you have an automated way to block these malicious attacks once you've detected them. Now, of course, some things in your environment are safe to quarantine and some things are not. So you really need to have a flexible policy engine that provides different actions for different device types. And it's helpful if your threat analytics system knows what each device is so that it can use some finesse in terms of taking actions to block attacks. So there you have it. That was just a quick look at one of the techniques in the MITRE attack for ICS knowledge base. There are a total of 81 techniques, as I said before. This is a very powerful tool that I urge you to become familiar with if you're not already. It's really good at helping you assess your defenses and identify gaps in those defenses. And security systems are available, such as the one that Armis sells, that provide comprehensive automated coverage for most of the MITRE attack techniques. Now, for more information about how to defend against other attack techniques, you can check out our blogs. Our people have published 5 blog posts, each covering a different attack technique. And I believe there's also a white paper from Armis that you can download from this virtual conference website or from Armis's website that describes all the MITRE attack techniques and how you can defend against them. So thank you, and I'll now turn the call back over to Dragos.
Thanks a lot, Jack. Really enjoyed your presentation. Just for the fact that we have some delays, let's say we are running a little bit out of time, I will jump with one of my questions, and then we'll probably need to share the stage to Bill. So sure. One question from my side. Since OT networks are now connected to enterprise networks, what is your view about an integrated security system for both of them?
Yeah, good question. I think I referred to that in my presentation. It's important. You can't secure OT unless you secure IT along with it. The world has kind of evolved into almost 2 different domains of security. You have your enterprise security products, which protect Windows computers, et cetera. You have your OT security products, which in a little silo over here. At Armis, we've designed a security system that monitors traffic from all devices. We can assess, we can build an inventory, we can assess risks, we can detect attacks from your ICS environment, as well as other systems. As I mentioned, IP video cameras, HVAC systems, iPhones, laptops. We see all these things in the environment of the ICS system. So we think it's very important to have an integrated broad scope system. Thanks
a lot, Jack. Really good answer. If there are, I think there are already a couple of additional questions, but please answer to them offline. As I said, we are a little bit out of time, so we will need to go to our last speaker for this track, William Stearns, and he will be talking about identifying compromises through device profiling using open source tools. And I will also do a short intro on William, or Bill, how we also call him. So Bill provides customer support, development, and training for active countermeasures. In support of those roles, he has authored numerous articles and tools for client use. He also serves as content author and faculty member of the SANS Institute, teaching the Linux system administration, perimeter protection, security in Linux and Unix, and intrusion detection tracks. Bill's background is in network and operating system security. He was the chief architect of 1 commercial and 2 open source firewalls, and is an active contributor to multiple projects in the Linux development effort. His spare time is spent coordinating and feeding a major anti-spam blacklist. Nice. And Bill's articles and tools can be found in online journals and in GitHub repositories and also stearns.org. So Bill, the stage is yours. Thanks for being here.
Good afternoon, everybody. It's a real pleasure to be here. Thank you, Dragos, for your introduction. As we said, I'm a software author and product designer, also chief technical officer for Active Countermeasures and a computer security instructor. I'm going to be introducing a tool today called DevProf, and we'll talk some more about what that's going to be, how that'll be used in the next few slides. I want to talk a little bit about the problem first, and that is network devices. As Jack mentioned in his presentation, one of the concerns are devices that do have internet access, whether they're supposed to or not. Jack's exactly right that a temporary firewall fix is put in to allow a device to pull down patches or new firmware. The firewall fix is never closed, and so that device may end up with internet access much longer than you expect. Even for the devices that do need regular internet access, one of the concerns is what happens if those devices decide they're going to send more traffic than they should, or start sending traffic of a different type. So in this example, this works for almost any device that has an IP address, but we're just going to use a warehouse camera as our example. In this case, these are cameras that are sending static images back to an analysis console of how the warehouse looks. And so just very light traffic, 10 megabytes a day is usually the right range for these. What happens if one of those devices starts sending hundreds of megabytes or gigabytes of traffic during a day? Is that a problem? Well, it may be. And that's what we're trying to do in this process, is use that traffic and use the fact that there's too much bandwidth being used as a threat. Threat hunting is looking for devices whose traffic to the internet is unexpected or unwanted or malicious. Similarly, if another camera decides that it's going to send traffic using an unexpected protocol, we can identify that as well. So we're going to use these type of clues to identify systems that are sending traffic they shouldn't. The tough part over on the IP side is that all of this traffic is mixed together on the wire. There's no one easy way to go and separate them out and say which of these types of traffic flows are expected and which are not. So what we're offering today is a way to make a profile of these devices to find out whether they're sending traffic that they should or should not. In device profiling, we're going to look at, as I said, IP connected devices. I realize that that's not everything that you can find in an IoT environment, but these are the ones where there's active communication out to the internet. And so we want to focus on those. We'll leave the rest of the environment to Cisco to handle all of the other aspects. So as I said before, we're looking for both the types of traffic that they're sending and the quantity of traffic. And we're going to report if a particular device is using too much or too little or the wrong types of traffic. Let's take a look at the tools. The first one that we use is called Zeek. If you're familiar with the open source IDS called Bro, it's the same product. It was renamed a little while ago. Zeek's job is to watch network traffic and summarize the different traffic flows that go by. So we can run this on a span or mirror or tap port. We'll summarize the types of traffic that have gone by on the wire. And that output is then fed into the tool called DevProf, or device profiling. This one is told, here are the types of traffic that are acceptable for these particular devices and IP addresses. Report if anybody goes out of spec. Let's take a look at how that happens. In this simple example, we're going to use two warehouse cameras. We're actually a bunch of warehouse cameras, and we're going to set up a profile called W_cams. In the line on the screen where it says WCAMs, the first one is where we specify what type of traffic is acceptable. It needs to be on TCP port 443 and needs to be encrypted, which is where the SSL portion comes. And then over on the right-hand side, we say, what's the appropriate range of traffic? And in this case, it's anywhere from 0 bytes to 10 megabytes. The last part of setting this up is that I also need to go down and say what address range or ranges are attached to those profiles. So in this very simple example, I have up to 256 devices whose IP addresses start with 12.13.14, and all of them have the WCAMs profile. You can actually assign more than one profile to a particular device or address range. So this gives you the flexibility to have multiple profiles for a given IP address. I haven't included IPv6 in this particular example just because it doesn't fit very well on a slide of all of the problems to have. When I run the DevProf tool on 24 hours worth of Zeek logs, here's what we get. The first example shows a webcam 5, 12.13.14.5. And if you'll notice, in the red circle, we show that it's communicating on port 8333 TCP. If you're not familiar with that, that's the port most commonly used by Bitcoin mining software, which makes very heavy use of the processor on a given device, possibly even overheating it depending on how well it's designed. In this case, it sent 5.5 gigabytes of traffic to and from the internet on a port that wasn't allowed in the first place. In the second example that starts with IP address 2601, this is communicating on an approved port, 443 TCP SSL encrypted, but the problem is that it's sent and received 916 gigabytes of traffic instead of the 10 megabytes that we were expecting. So this as with every other investigation, it raises the question, is this a problem or not? It's entirely reasonable to me that one or more people in our office decided that, hey, I'd like to have a live stream from that camera running 24 hours a day, reporting back to my desktop. And that's why this particular camera is sending and receiving so much data. But I don't know that. So that's where I need to go back to this device, look at the IP addresses with which it's communicating, and figure I'm not, there we go. Pardon? Thank you for your patience. Great. So with each item that we find on this report, there are two basic approaches. If I look at something on the report and I realize that the traffic that's happening is legitimate, but it's just too much, I can go back to the original profile files, up the numbers a little bit, expand the range, and then DevProf will stop reporting on that. If the traffic turns out not to be legitimate, I can create a trouble ticket, do the forensics on the device, open up an investigation as needed, figure out where this attack is coming from, whether the machine is broken into at all, and if needed, shut the system down and or firewall it off from the internet a little more carefully. Finally, by rerunning the report after we've protected against that traffic entering or leaving our network, then I should see that traffic disappear. If it's still there, then we need to check the firewall rules. What's the practical use of this? This sits alongside your other security tools. It doesn't really replace any particular tool that you already have, but we want to let you build up a profile that matches your systems, embedded systems, IoT, IIoT devices, and if you choose, even laptops and desktops. The quirk is that laptops and desktops with general purpose operating systems are tricky to profile well because so many people are doing so many things on so many ports that it can be more work than it's worth. And that's why we're focusing this tool on embedded devices that have less of a footprint, network footprint. Once you build up the profile, tune it a little bit each day, try to cover the legitimate traffic, and then over time, what you'll find is that the report you get each day is going to be more and more unwanted traffic. And that's your chance to go and focus on that and say, why is this traffic here in the first place? There's no agent to install on any of the machines that you use, so you don't have to worry about operating system compatibility. You're simply watching the network traffic on the wire. And it will also report on unwanted devices that show up on the network if you want it to do that as well. If you have any questions, feel free to put them into the questions window. Zeek can be found at zeek.org. This is not a tool that we provide. This is an open source in IDS that's available and used very widely across the internet. DevProf we do provide, and it can be found at the URL on the screen. We provide other threat hunting tools at github.com/ActiveCM, and I neglected to put our website URL on there as well. Just like my email address at the bottom, it is www.activecountermeasures.com. We have other free and commercial threat hunting tools, and would be happy to answer any questions there, along with a Discord server for other discussion. My email address is on there, bill@activecountermeasures.com, if you have questions that aren't answered during this presentation. Thank you, everybody. We appreciate it. Dragos, back to you.
Thanks a lot, Bill. And just to add here, I've been in fact using Zeek like recently as a IPS IDS in some IoT scenarios. So I was really interested to see, and I'm curious to see how to integrate it with the profiling tool that you mentioned. So I will check it out for sure. While we are, because I think we have still a couple of minutes for a Q&A, short Q&A. Let me jump with a couple of questions from my side. Do you run this, the profile that you measure, do you run it on every machine?
No, actually, this will just be run on a single computer that has access to the Zeek output. So you'll run Zeek at one or more points in your network where you have a choke point. Then the DevProf tool can run on that, either on that same machine, or if you're running short on processing power on a different machine nearby. But no, you don't have to run anything on the individual machines in your network.
Okay, understood. And next one, what operating system do I need in order to run this Zeek and DevProf?
Zeek is largely Linux, although it will run on Mac OS. DevProf will run on any operating system that has the Python programming language. It may seem a little odd to send something out as a Python script, but we actually prefer using that for our open source tools because you as an end user can see exactly the code that's going to be run as it's going to be run. So if you're in a high security environment and you don't trust us, which is just fine, you can tell exactly what the code is going to do long before you put it into production.
Okay, thanks a lot. I think one last question from my side. In terms of traffic and the protocols used, what type of protocols are supported by the DevProf and the Zeek?
Sure. Those are largely IP-based protocols. So you need something that has an IP address and has the ability to either receive connections from the internet or send connections to the internet. Other than that, there's no limit on how you set up your profiles for TCP, UDP, ICMP, or any of the 252 other IP-based protocols that are available. Almost anything you can come up with, you can set up a profile for.
Okay, so protocols like, let's say, MQTT or Modbus, or even some more proprietary protocols, how would you be able to integrate them with Zeek and DevProf? Would you be required to have like a maybe IoT gateway somewhere in the middle to translate some protocols, or how would you do it?
That's exactly right. DevProf and Zeek don't have the ability to look at the other protocols, but if you have a gateway that allows these devices to either accept connections from the internet or send connections to the internet, you can look at the traffic just beyond that gateway to identify the IP-based communication that's created in response to the Modbus requests.
Thanks a lot. Great answer. Bill, that's all. I think we are quite in time. We managed to be in time. So thanks to everyone. Thanks first to the sponsors. Thanks to all the speakers. Thanks to all the attendants. Hopefully the track was interesting. For me it was, so it was a pleasure to coordinate these cool gentlemen, as I said also in the beginning. And in case there are additional questions, please do not hesitate to ask them. Most of them also shared LinkedIn contacts, email addresses, so I'm sure they will be glad to have you on their social media or on email exchange. So thanks a lot again, and looking forward to be in touch with you.
Thank you all for joining. Thank you, the sponsor, Adolos, Active Countermeasures, and Armis for this supporting our event. And there's a couple more sessions, so feel free to stick around, take a seat in another session. Have a great rest of the day.